All right, so we talked about adding. Adding is no problem. Adding's easy. Subtracting causes kids problems. And I know it sounds silly, but it actually does. The first thing we need to remember is subtraction isn't a thing. It's not real. Math guys are lazy, so they invented subtraction. So, subtraction, and I'm so lazy, I'm only going to write sub. Subtraction is adding negatives. So really, if you write, for example, x minus y, what that really is x plus negative y. But math guys are so lazy, they don't want to write that way. That's what's happening. Everybody cool? So 7 minus 5 isn't real. What it actually is 7 plus negative 5. That's it. And yet, subtraction causes people problems. Even when I let you use your calculators, kids screw up subtraction. Okay? Let's try to not screw up subtraction. That's my goal.
Sounds like what I do.
Okay? So, what would this one really be? It would be negative 6 plus, now, this 5 became a negative 5. So what is that negative 3 going to become? A positive 3, and we are going to get an answer of negative 3. I forgot to put the answer there. Down here, negative 2 plus the 9 becomes negative 9. And if I have negative 2 and then negative 9 more, I end up with what? I'm asking you to do a little bit of math in your head. If I'm at negative 2 and I go negative 9 more in the negative direction, where do I get? Negative 11. See how easy it is? In your head even. And yet, when I give these questions on tests, kids get them wrong. And part of the reason you get them wrong is you punch stuff into your calculator, hit the wrong button, and then believe your calculator, even though it makes no sense. Right? All of you have done that. I've done that. Okay, so there's a lot of ways to remember how to do this and make sure you've got the right answer. I find the easiest one is what we just did here. Okay? What we do is we change minus to plus, and we change the second sign. So this 6 minus 2 becomes 6. Change the minus sign to a positive sign, and change that to negative 2. And this one's easy because it's 6 minus 2, so we know it's 4. Right? These are the ones that cause kids problems. Because if I ask you to tell me that answer right there, I'm going to get a bunch of people giving me different answers. But the easy way to do it, don't touch the first number, change that to a plus, and change the second one. It's already negative, so I make it positive. Negative 8. What direction are negatives on a number line? Left or right of 0? Left. So I would go all the way down to negative 8. And then what direction are positives? So I'd go all the way back up to negative 3. Right? I know this seems lame that we're doing this, but all the math we do in this room is going to be add, subtract, multiply, and divide. So if everybody kicks ass at add, subtract, multiply, and divide, you're all going to kick ass at this course. Does everybody understand? Because that's all we're going to do here. It's add, subtract, multiply, and divide. So negative 4 plus 7, negative 4. We don't touch the first one. Change the sign. Change the sign. Negative 4 plus negative 7. And what do I get? I'm already negative. I'm going more negative. So the answer is going to be negative 11. So easy. Now, again, I am forced by my bosses to do this stuff over here, right? I know that all of you can add and subtract. I know that. You know that. But I am forced to show you this. I will show it to you once, then I have done my job, right? So, find the starting point. If we're using a number line, the starting point is always the first number. First number. If I'm subtracting, I move left. Okay, so somebody say a number. A positive number, please. Okay, 2. Now give me another number.
5.
Minus 5. 2 minus 5. So on a number line, we go to the first number. First number is 2. Where is 2? Left or right of 0? Right. So I go 1, 2 to 2. Then a minus sign means I move left. So I go back. How far? No, I go back 5. 1, 2, 3, 4, 5. And there's my final answer, -3. I've shown it to you. You all get it, yes? Everybody nods now, and then I've done my job. Right? Thanks, Brody. Now, what if you come to a negative sign? Then you change directions. So, somebody give me a number. 3. Give me another number. That would be a big number line. But just because you're being a wise ass, I'm going to do it anyway. Minus -77. So, does anything change? Does math change? Isn't 2 plus 2 always 4? Everywhere in the universe? Math doesn't change. So this math doesn't change. I start at 3. Where's 3? Right or left of 0?
Right.
Right. 1, 2, 3. There I am at 3, yes? Now, subtraction means I'm supposed to go left, right?
Yeah.
Left, right. Subtraction means I'm supposed to go left, correct?
Yeah.
But when I go left, I hit a negative sign at 77. So what do? I change directions. So I actually go 77 this way to get to a total of, I was at 3, then I moved 77, so what do I get? Oh man, 77 plus 3. Brody, save the day. Landon, what's 77 plus 3? Plus 3. 80. That's all you do. Nice job, Landon. Don't let fake Rubik's Cube man over there mess you up. It's okay, buddy. I had Rubik's Cubes too when I was a kid. But mine were only 9 by 9. Or 3 by 3. Yeah, like that. I also had a Pyraminx. I could never figure out the pyramid. You know who was the rock star of the pyramid in my house? My mom. My mom could kick a pyramid. Well, we called it Pyraminx because that's what it was named. Yeah. My mom kicked the Pyraminx's ass, which always made me feel bad because my mom was 1,000 years old. She actually wasn't. My mom's only 26 years older than me. So when I was, 8, she was only 34, which wasn't very old. But when you're 8 and your mom's 34, she seems like she's 1,000, right?
My sister, could do Rubik's Cube really well.
I learned Rubik's Cube fairly well. I had to learn. It took me a long time. Many years of taking it apart first. So, well,
10 minutes to solve this.
I've never played with one of the 4x4s, but I assume it follows a similar pattern to.
Yeah, after you put all the groups of 2 together.
It's groups of 2 instead of groups of 1? Yeah, okay. Well, group of 1. You know what I mean. Corners together and then match, right? So on that one you put.
Yeah, you have to build the centers.
You build the center first and then out. And on the other one you build the outside in.
And you have to put the centers in very specific spots.
Yeah. Okay. So, multiplying. Multiplying's easy. Very rarely in this class are the numbers we multiply going to be normal. Like I could ask you to do 2 times 8 and you would all go 16, right? But normally in this class, the numbers are going to be bigger or they're going to have decimals. So you're not going to be doing them in your head. You're going to be using your calculators for everything. But here is something that you need to remember. The answers still need to make sense, right? If you punch something into your calculator, you get an answer that makes no sense. Should you write it down on your assignment? No. You got to be responsible. So if I'm going to multiply integers, what happens if I multiply a positive number by a positive number? What will I get? Remember, Math never changes. What's 2 times 3?
I'm sorry.
Somebody said 6, but somebody said 4. I was a little worried. I'm a little worried right now. I'll try again. What's 2 times 3?
6. Wait, 9, sorry.
No.
Wait.
No. 2 times 3, kids. I want 2 times 3.
It's 6.
It's positive 6. So, if something happens once in math, how often does it happen? Every time, because math doesn't screw with you. Right? No, it doesn't.
What about imaginary numbers?
So, positive times a positive is a positive. They're the same sign, so we get a positive. What happens if I do a negative times a negative? Are they the same sign? Are they the same sign?
Yeah.
So what's my answer going to be?
Negative.
No.
Oh, sorry.
Same sign is positive. Now you're smart kids. What if I have a positive and a negative? What's the answer going to be? It's going to be negative. That's it. So when you're punching stuff into your calculator, before you bother with plus and minus, just look. If one of the numbers is negative, you know your answer is going to be negative, right? And if your calculator gives you a positive number, you know you punched something in wrong. Clear? Don't go to your calculator until you have some idea of what the answer will be. So that way, if it gives you garbage, you know it's garbage. Are we cool? Okay. Again, you're smart young people. Are multiplying and dividing related? Yeah, because 2 times 3 is 6, and 6 divided by 3 is 2, right? So what would happen if I did a positive divided by a positive? What will the answer be? Positive. What if I did a negative divided by a negative? Are they the same sign? So I'm going to get a positive. What if I did a positive divided by a negative? He waited patiently. What would the answer be? Negative. Nicely done. Everybody good? Ease, bees, lemon squeezy, yeah? Okay. Now, you don't have to write down what I'm about to put on the screen. You can do it in your head. Some of you won't bother doing it at all. Some of you are very tired. You've had a long day, even though it's only second block of Monday and you need to rest. I understand. So, put those numbers in order from least to greatest. So what of those numbers is the smallest? Just do it in your head. If you can find a little space on your white paper, you can write it right there. This is just practice. Put the smallest number on the left and work your way up. And after we finish this page, we will take our first stretch and a mental health break. Because 80 minutes is too damn long to do math in a row. Am I right, Lou? Damn right I'm right. Who wants to do math for 80 minutes? Now, would anybody like the magic pen and the wireless computer to write the numbers, the right answers right there? No? Nobody wants to try? What if I paid you with 2 gummy bears? Yeah. I would pay you with 2 gummy bears. No. What's the smallest number there? Nyla, hit me. Damn right it's -4. Nice job. See, Nyla, you already would have been part of the way to earning a gummy bear. There's no spot for you to write it. Lincoln, it was anywhere you had space, or you could just do it in your head. It's just practice. Brody, what's next? -2. Look at this guy. What's next? 0. Then 1. Then 3. Then 7. Everybody understands how numbers work, right? What is this course? Math. What is the language of math? No. Numbers. Does everybody know how numbers work? Everybody knows how numbers work, right? So should anybody have any trouble with this class? No. Okay. No. Okay. This is the 4th time I'm going to say it. This page is not in your notebook. You have to think. Okay? Or, if you want, you could write out your answers Anywhere you have some space. All right? Silas. The font is scary because math is scary, actually. The font is Bloodthirst is the name of this font. So, use a number line to show me this. There's a number line. Where do we start? We start at 0 and we go to the first number, which is 7, right or left of 0? Right? So I go out to 7 plus 3. Plus means I go what direction? Right. I go 3 more. Where do I end up? Plus 7 plus 3. What's the answer? 10. Easy peasy. Now do it with those two. So where do I go first, Brody? Your answer's right, but I want... Explain it to me. Pretend I know nothing about numbers. I'm an alien from another planet, and this number means nothing to me. Oh, I do math, but I do math my own way. I need to know your math because I've moved to your planet and I would like to learn your numbers. So I go 8 over. What does over mean? 8 to the right. 8, then what? I go back 6, and where do I end up? 2. Easy peasy lemon squeezy. Right? And how do I do the third one? Where do I start?
-3 to the left.
So I go left, 1, 2, 3, -3, and then what?
+7.
So I go right how far?
7.
So 1, 2, 3, 4, 5, 6, 7. And where do I end up? +4. Easy peasy lemon squeezy, yes? All right. How many of you remember the little square thing that I showed you? What does that represent?
Positive. Or negative.
1. +1. So how would I show 5? I'd draw 5 of them.
Oh, I thought you were putting this colored in.
Yeah, it doesn't matter. What do I do for this? Draw out 2. How many little squares do I have? How many little shapes do I have? Because Brody's going to say, some of those are circles, some of them are ellipses, some of them are dodecahedrons. How many do I have? 7. How do I do this one? What do I do for the 6? I draw 6 little squares. How do I do -4? Come here. No. Because you've been on your phone, you're not writing anything down. Huh? Okay, you can go to the bathroom when you tell me what to do here. Because that'll show me you know what you're doing. So you don't know what you're doing, so you better pay attention, right? Maybe you go to the bathroom in 2 seconds when I say we're taking our first little break, right? Because you obviously don't know what we're doing here, yeah? Okay. Nyla? Right. I could draw 4 more, and then they would cancel, right? Or I could color in 4 of them, they would be negative. And my answer would be 2, yeah? What do I do for this one?
Draw 3 negative.
How do I draw a negative?
Color it in.
Shade it in. 1, 2, 3. Then what?
2 more.
2 more negatives. And what's my answer?
5.
You count. -5. Done. Easy peasy lemon squeezy, yeah? Okay, before we start the next one. Oh, that shouldn't have been there. We don't need those. Before we start the next one, we'll take a 3-minute break. Kabir, go.
Can I also go to that?
One person from each cisgender can go to the bathroom. Huh? What's what? Because I'm not talking about pronouns. I'm just saying one person in each of the rooms. And then we're going to get to fractions. I want everybody to be ready for fractions. So take some deep breaths. Play with your Rubik's Cubes. Because fractions are a pain in the butt. But, no, let me see if I can... No, that isn't what I wanted to do. I was going to make a pattern. I know you can, but I wanted to make a pattern and now it's ruined. Never mind, Brody. I'll just sit here and pout and drink my coffee.
Mr. Myers,
I will pout and drink coffee.
Mr. Myers, Mr. Fryers.
That's awesome. Every time I pout, I want you to call me that.
All right, Mr. Fryers.
I love it, but only when I'm pouting. So I'm not pouting now, right?
So I can make you pout.
Probably. Watch. What's 2 times 3? See? I will pout when kids tell me that 2 times 3 is 8. That would make me pout. But, Brody, what is 2 cubed? No.
Oh, cubed. Oh, 8.
8. Ha 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 ha. That's okay. Honestly scared of fractions. Thank you for being honest, Brody, because there's no way you're the only hand that's up. If not any of you are scared of fractions, then you all could do everything I'm going to ask you to do right now without me teaching you. So you could all do 37 49ths plus 84 91sts, right? No, of course you couldn't. So I'll ask again. How many people are scared of fractions? That's a little better. Okay. First of all, let us talk about what a fraction is. A fraction looks like this, right? Some number over another number, yeah? Now, I told you that I like to use the real names of things, right? So, does anybody remember what we call the number on top of a fraction? The numerator. Well done. And does anybody remember what we call the bottom number in a fraction? The denominator. Nice. Excellently done. Now, can you explain to me the relationship between them? They share a line. Oh, I'm actually glad you brought that up, Brody. What math is that line divided by? Because remember, how many types of math are we going to do in this class? Oh man, I just said it. 4. Thank you, Jessica. What are those for? Add, subtract, multiply, and divide, yeah? So this is division. All fractions are is dividing. All of you know how to divide. If I tell you I have $20 and I'm going to share it with 4 people, how much does each person get? You would all know it's $5. So you can all do fractions. People say they can't, but you can. No, multiplying fractions is the easy one. That's the easiest one. Okay, how many circles did I draw? 1. Easy peasy, right? So if there is a whole circle there, my denominator is 1. How many circles do I have? 1. So I have 1 out of 1, right? That's what that means. That's all a fraction is. If you get this score on a test, what do you say you got? 7 out of 10. So there were 10 questions, you got 7 of them right. Agreed? If you can read that, you can do fractions. What if I cut that circle into that many pieces? How many pieces do I have, Kabir? 4. So that means I have 4 pieces. Now, right now, I have all 4 of them colored in, yes? So what number would I put here? 4, because 4 out of 4 are colored in. What if I did this? Now how many are colored in? So it's 1/4. That's all fractions are. The amount you have over the total amount there. Just like a math or a quiz score. Is everybody good? Okay? That's it. That's all there is to it. What if I drew this? What would the blue one be? Right now it's in thirds, so the 3 would go where? Top or bottom? Bottom. And now what would I have? 1/3. What would I have there? 2/3. Now, if I wanted to add them together, you can't do this because I'm magic. I know, right? They're not the same size, are they? Are they the same size? No. So, here is what I mean by that. Don't draw this, I have 2 pizzas. Let's pretend those are pizzas. We're not going to talk about toppings because nobody can agree on toppings because some of you crazy people want pineapple on your pizza, and that's nuts. Pineapple has no place on a pizza. So, how many people like pineapple on their pizza? Only 1? New record. Yes, this is the best pizza class ever. Because only 1 person would ruin it with pineapples.
Whoa. I got it from my sister.
It's okay. I'm just joking. See? I'm happy. Smile.
You're not joking.
I am joking.
You're not joking.
I love pineapple on pizza. No, you missed me barfing. Okay, so I'm going to share my pizzas with Landon, Lincoln, and Brody. Right? Everybody cool? Okay. I'm going to cut this pizza like this. And I'm going to cut this pizza like this. Everybody agree? I'm going to give 1 piece of pizza to Brody. I'm going to give 1 piece of pizza to Lincoln. And I'm going to give 1 piece of pizza to Landon. Is that a fair split? No, of course not. Because how much did Brody get? Half a pizza. How much did Lincoln get? Half a pizza. How much did poor Landon get? 1/8 of a pizza. So, if I have 2 different fractions, half and 1/8, can I put them together and keep it fair? No. That is what we have to remember. When we add or subtract, we need common denominators. Okay? You get common denominators. To get these, you use multiplication. And I'm going to show you what I mean in a second. Even though most of you probably remember this is about grade 5. All right, so I know everybody hates when we put the letters in math, yes? But we all remember, what is a letter in math? What does it really mean? It's just a number, right? So, A over B. Is that a fraction? Is that a fraction right now? Of course it is. We don't know what the numbers are, but we know there's numbers there because there's letters holding the place for the numbers. Agreed? Okay. What if I add C plus B? Are those the same denominators? Because when you use the same letter, you have the same number. So how would I do that? That is A plus C over B. And you all know that already. Right? Easy peasy lemon squeezy. That isn't a problem. But when we do this, it becomes a problem. A over B plus C over D. Are they the same number? No. And now we have a problem. Now there's lots of ways to fix this problem. There are shortcuts, there's all kinds of things you can do, but I'm going to show you what I think is the easiest way to fix it. I'm going to get some different colors going. You multiply this way, and your new denominator becomes B times D. And then you multiply diagonally. So this becomes A times D plus, then you multiply this way, B times C. And it always works. Everybody cool? It's one step. Are you allowed to use your calculator to do this multiplication? Yes, of course you are. This isn't grade 2. I let you use your calculator. Why? Because in the real world, you would use your calculator, yes? Okay, so let's make sure You're really cool with this. What is 16 over 19 plus 1 over 19? 1 second. Brody, hit me. 17/19ths. Done. Why were you able to do it that fast? What made it that easy? They have the same denominator, right? What if I had this? And I'll change color slightly. 3/4 plus 1/2. Nope, sorry, not 3/4. 1/4 plus 1/2. Yeah? Comes out to 3/4. No, 3/4. You're multiplying, kind of. Why is that 3/4? They're not the same. And if I do 2 times 2, I get 4, yes? And if I do something to the bottom, to the denominator, what must I do to the numerator? Same thing, because they're partners. They come as a group. So that is 2. 1/4 plus 2/4, 3/4. So easy, yes? Right? No problem at all. When do fractions become a problem for all of you? When we do this. 7/8 plus 3/5. Now it's a problem. Right? Now, most of you have calculators that don't do fractions. There are calculators you can punch fractions into, but most of you won't have that kind of calculator. So we have to do the math. Now, does this look like this? Yes. So our new denominator, b times d. What do I do with 8 and 5? Multiply them together. If you don't know your times tables, what are you going to use? A calculator. What's the answer? 40. What do I do with 5 and 7? What do I do there? Times 5 times 7 plus, what do I do there? 8 times 3. Can I use my calculator? Of course I can. And what do I get? 35 plus 24 over 40. 59 over 40. Now, you have had teachers in the past that have said, if you stop there, they would take out their red pen and mark the whole thing wrong, wouldn't they? All of you that have had a math teacher that will do that to you, yes? You didn't simplify, so it's wrong. You've only known me for 3 days. Is my red pen that type of a weapon? No. This is math class, yes? If there's more math that you can show me, you should show it to me, correct? But what if you stop part of the way there? Should you not get part of the credit? Will you get part of the credit from me? If you stop there and this question was out of 3, what do you think I would give you? 2? I would give you a C+?
No, sorry.
3? It's perfect? You showed me all the math you could show me? Yes. Does everybody understand? So you get to relax a little in this class. Oh, I forgot one little step. I am not going to change, or I'm not going to mark the whole page wrong. Are we clear? Now, of course, how do we finish that? You all know. How many 40s fit into 59? 1. How many are left over? 19. Does everybody remember adding fractions? Okay, let's try a couple of nice, easy ones. What is 3/4 plus 5/4? What is it? It would be 8/4, which would also be, now, Brody, 2. So easy, yes? Same number on the bottom, easy peasy. What would 3/4 plus 1/2 be? What's going to be the denominator? 4. Did I change 4? So do I change 3? No. Did I change 2? What did I do to 2? Times by 2. So what do I do to its partner? Plus 2. What's 3 plus 2? If you stop there, do you get full marks? Not full marks. How would you make that full marks? Simplify it. How many 4s fit into 5? 1 with how many left over? 1/4. Everybody cool? That's a B. That's an A. Does everybody understand the difference in my room? I know in the past, you've had teachers that would, if you left it there, they'd give you wrong. Correct? I'm not that guy. Everybody good? All right. Let's try a slightly more difficult one. I'll let you choose the color. Green, boring, but okay. 2/3 plus 3/4. Are they the same number? So what's the easiest way to make them the same number? Multiply them together to get 12. So the 4 has to come up here, and the 3 has to come up here. What's 2 times 4? Plus, what's 3 times 3? What's 8 plus 9? 17/12. Do you have your A? No, you've got a B. Do you want an A? So how many 12s fit into 17? 1 and 5/12. Is math always the same? Yeah. So if you know how to add two numbers, you automatically know how to subtract them, yes? So if you know how to add two fractions, do you automatically know how to subtract them? Of course you do. What would happen if I gave you 7/12 minus 5/8? This one is super tricky. Would you be allowed to do 12 times 8? You could, but that'd be a big number, yeah? You could try something smaller, yeah? The lowest common multiple, which is what? What's 24? So Brody says, I know my times tables. 12 times 2 is 24. 8 times 3 is 24. There's my common one. What did I do to 12 to get it to 24? So what do I have to do to his partner? What did I do to 8? So what do I do to his partner? What's 7 times 2? 14. Minus, what's 5 times 3? What's 14 minus 15? 1? -1 over 24. Nothing changes. Easy peasy lemon squeezy, yes? Now, okay, what would you do with this? 2.5 plus 3 2/5. There are two ways to approach this question. If you don't remember, that's okay. But if you have an idea of how you would start this, and you're willing to, what would you do? Junior? You would go with improper fractions? Okay. Do you remember how to do that? What's the shortcut to doing that? You multiply here and then what? Add up there, right? So I'm just going to show you that if I have A, B over C, and I want an improper fraction, I do C times A plus B. So what is 2 times 2? Plus 1, 5 over 2. Plus, what do I do here? Multiply and add. What's 5 times 3? 18 plus 2. 18 plus 2. 17. Thank you. I was doing 6 times 3. Now, is it the exact same? Exact same as over here, right? I would just do the work. Everybody cool? Finish it. What would you get? What's my new denominator? 10. What goes up here? 5. What goes up here? 2. 25 plus 34 is 59 over 10. Right? And if you want the A, how many 10s fit into 59? 5 with how many left over? 9 over 10. Everybody cool? Now I'm going to show you something else that you might like better that you might not have seen. Go back to here. If there were no fractions, what would you do with 2 and 3? If there were no fractions, you would just add them together, right? What would you get? 5. And then there was 1/2 and what was it? I erased it. I don't remember. 2/5. Then you could add 1 plus 1/2 plus 2/5, which would get you 9/10. 5 and 9/10. You can leave the big numbers big. Now, let me ask you this. Do you think I care what way you do it? I'm glad I can read the sarcasm in your voice, Brody. I don't care how you do the math, do I? Whatever you are comfortable with. So, Junior, you suggested going to improper fractions. You're probably going to do that every time, aren't you? But you don't have to. Everybody cool? Everybody good? Would anything change if it was subtraction? Of course not. Are we all good with adding and subtracting fractions? We're going to do it a lot, right? But you've all seen it before. We're pretty cool with it, yeah? Okay.
I don't understand the part when you finish and you say that you have an 8, where it puts 59 minus 10.
59/10
Yes, what you do there, I don't understand.
to get to there?
Yes.
Okay. That's easy to show, Lou. These are both in quarters, yes? So how many quarters are over here? 4 quarters, yes? And here is 1 quarter, yes? So that is same number on the bottom, 4 plus 1, 5 quarters, yeah? Okay. How many quarters are here? There's 4, so that makes 1, doesn't it? And 1 quarter there, yes? So 1 and 1 quarter is the same as 5 quarters. How many 4s can fit into 5? 1. And then there is 1 quarter left over. 1, 4 quarters plus 1 quarter left over. Cool? So if I had 17 over 3, how many 3s will go into 17? Okay. How many 3s will fit into 17? 3, 6, 9, 12, 15. So 1, 2, 3, 4, 5. And then I'm left with 2 of them. 2/3. Cool? Everybody good? Okay. Now, my good friend Brody said he doesn't like multiplying fractions. That's what bugged you, yeah? All right. So we're going to start nice and easy. Now, first thing, for multiplying, dividing fractions, see right up here where it's blank white space? I'm going to use a big pen, and I'm going to use my favorite color, no, LCD. What does LCD stand for? Lowest common denominator. No LCD for times and divide. That is the mistake kids make. Your teacher spends so long talking about common denominators when you're adding that it gets stuck in your head and you think you always need them. Do you need any lowest common denominators on this whole page? No. No LCDs for this. So let's start with the first one. We're cool enough that I can go straight to letters, right? Right? So, is that a fraction? Sure it is. Times C over D. Do they have a common denominator? Do they need one? No, because not when you're multiplying and dividing. All you do is go straight across. A times C over B times D. And then, what must you remember to do if you want the full marks? Simplify. Now, simplifying here is probably what's causing problems. You can simplify at the end. You can simplify at the beginning. And you can simplify in the middle. There's all kinds of spots to simplify. Who decides where you like to simplify? You decide, right? Okay, so let's start with a nice easy one. 2/3 times 1/2. Does that red look exactly like the blue? Of course it does. So what do I do with 2 and 1? I multiply them, 2 times 1, and what do I do with the bottom ones? Multiply, 3 times 2. Now this 3 times 2 caused a lot of trouble a couple of minutes ago. What's 2 times 1? And what's 3 times 2? 6.
Oh, God.
Now, can I simplify that? How? Simplifying makes numbers smaller, yes? So we're smart people. When we had to make the numbers bigger, like in adding, we multiplied, yes? So what makes the number smaller? Divide. Is there a number that divides into 2 and divides into 6? 2. What is 2 divided by 2? 1. What is 6 divided by 2? 3. Done. When did we simplify? Beginning, middle, or end? End. Could we simplify at the beginning? Sure we could. What do you see right there and right there? 2. So if I have the same thing on the top and the bottom of a fraction, isn't that just 1? So that becomes 1 and that becomes 1. Now 1 times 1 is 1, 3 times 1 is 3. Does everybody understand? Okay, so let's do one that you have to simplify at the end. 3/5 times 4/3. Nope, sorry, not 4/3. I don't want to do 3. 4/6. Actually, we could simplify that in the middle too. But we're going to simplify at the end. What do you do with 3 and 4? 3 times 4. What do you do with 5 and 6? And what do I get? 12/30. How can I make that better? Divide by 2. That will get me 6/15. Can I make that better? How? Divide by 3 to get 2/5. Is everybody cool? All right, let's do one together that you can simplify at the beginning and the end. Oh, that'll be a good one. Let's go with 8/21 times 28/64. So, look everywhere. Is there a number that works with 8 and 64 or 21 and 28? 8. If I divide that by 8, what do I get? 1. What is 64 divided by 8? 8. Does any number work with 28 and 21? 7. What's 28 divided by 7? 4. And what's 21 divided by 7? 3. What's 1 times 4? 4. What's 3 times 8? 24. Does that get any simpler? To what? What number works with 4 and 24? 4 and 2. 4 divided by 4 is 1. 24 divided by 4 is 6. And we're finished. Is everybody good? Okay. Now, what if they're mixed numbers? Somebody give me a number. 3, give me another number. 3, give me another number. 5. Times, give me a number. 3, give me another number. 3, give me another number. 4. How would I multiply those two? Do you think?
5 times 3.
Yeah, you have to make them improper. And we just did the trick, didn't we? What do I do with 3, 5, and 3? Multiply, and then what do I do with that answer and 3? So what is 5 times 3 plus 3? 18 over 5 times, what do I do here? What do I do with 4 and 3? Times, what do I do with that answer and 3? Add, what's 4 times 3? 4 times 3 plus 3, which is what? 15 over 4. And now isn't this the same as up here? So we're good to go, right? Okay, what's the key to this? Always improper. Let's do some practice. Everybody should do this on their own. This part, these easy ones, quietly. 3 fifths times 2 fifths. Take a moment. Figure it out. It won't take long. Give me the answer. You can use your calculator if you need to, of course. We are multiplying. So what is the answer? Everybody said you got it right here, so I should be hearing 28 people yelling the right answer to me, shouldn't I? 6 25ths. Why? Because it's 3 times 2 over 5 times 5. Easy, right? Okay. Let's try another one. Again, do this one yourself. 3 sevenths times 2 ninths. Change it. 2 fifths. I should again be hearing 28 people giving me the right answer. What is it? 6 35ths, yes? Okay, listen to me carefully. There's only 7 minutes left in class. We took a nice break in the middle. I'm going to write 4 questions here. You have 7 minutes, you could work on them. If not, you have 4 questions of homework. I know, right? Way too much. 15 over 7 times 2 over, yeah, 9, sure. That's 1. 2 and 2/7 times 1/4. -3 and 3/5 times 1/8. And the last one, which is the hardest one, negative, I'll keep the 3/5, but I want you to multiply it by -2 and 1/9. 4 questions for homework, and I'm giving you 8. Well, I lie now. Now we're down to 6 minutes to do it here.